So here we're going to try and solve this quartic equation. Z to the power of 4 plus 8z squared plus 4 equals 0. Now z here is our complex number. So z equals a plus bi, where a and b are real numbers and I is our imaginary constant, square root of minus 1. Okay, so where are we going to start to try and solve this quartic? Well, factoring this is not going to be very straightforward. Not sure how we go about that. But what I do see here, we've got z to the 4, z squared, and then a constant. So what I'm going to do here, I'm going to do a substitution for z to the 4 and turn it into a quadratic. So I'm going to set w equals z squared. So wherever I see z squared, I'm going to substitute a w. So let's change that in terms of w. So z squared, so here I've got w squared. Here z squared is just my w. And then plus 4 equals 0. Okay, now factoring this, I'm not sure what I'm going to do there. I could take the square, that would work, or I could go straight to the quadratic formula. So for this question here today, I'm going to use the quadratic formula. So, okay, so minus b plus or minus square root b squared minus 4ac over 2a, and that be for my w equals. Okay, let's go straight into that. So for this, I'm going to have w equals minus 8 plus or minus square root of b squared minus 4ac. So 64 minus 4 fours times 1, so that's 64 minus 16. So that's square root of 48. And that's all over 2. Okay, now can I get rid of this 2? Well, I can divide 8 by 2, of course, but square root of 48, we're not ready yet, so we need to get a 2 out of that. So if I take square root of 4 out of that, that'll leave me 2 root 12. So I've got minus 8 plus or minus 2 root 12 over 2. So now I can cancel my 2's. So they will cancel and that will become a 4. Now square root of 12 is 2 root 3. So now I can simplify this third as much as possible. So now I've got w equals minus 4 plus or minus 2 root 3. And that's, we don't need this 2 has been cancelled. So that's my solution for my w. Now w I substituted for z squared. So therefore this w is also the same result for z squared. So if I just write like that and then take the square root of this, and that will give me my solution for my z. Okay, so now I can write z equals square root. Now as I'm taking the square root on both sides, it's a plus or minus situation. And then inside my radical, I write this. So minus 4 plus or minus 2 root 3. Okay, so now I've got one of them awkward situations where I've got a radical inside a radical. Okay, now square root of 3 is 1.732, blah, 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 just a little bit. So inside here, I've got a negative value. So now I can transfer this into terms of I. So if I take a square root of minus 1 out of this, I can now rewrite this as z equals plus or minus. Now I'm going to take a square root of minus 1 out of this. So I'm now going to need an I in front. And then here I can just flip these signs. So now I'll have square root of 4. Now I can write minus plus instead, just to be algebraically correct. And then 2 root 3. Now, as that will include both solutions, I could still leave that as plus or minus, but I just want to show that as we've taken minus square root of minus 1 outside of it, that will be our net result. We can flip this plus or minus as well. Okay, So 4 plus or minus 2 root 3 and 4 minus 2 root 3. Okay, so why don't I rewrite this 4 plus or minus 2 root 3? I can rewrite that like this. So if I just write it like this, 4 plus minus 2 root 3. If I can write this in terms of square root of 3 squared and make this also like a quadratic. So now I can write square root of 3 squared plus or minus 2 root 3, and then root 3 squared is 3, so I now can add 1. So now I've created quadratic in kind of terms of square root of 3 being my variable, although it is actually a constant. So now what I can do with this is I can just factor that into a square. So now I've got square root of 3 minus or plus 1 squared. Okay, so then if I square this, I'll have 2 root 3's plus a 1 and a root 3 squared. And also if it's a minus, I'll have minus 2 root 3's plus a 1 and plus a root 3 squared, as I have here. So now I'm going to rewrite this in terms of this. So now I've got z equals plus or minus I. Now I can write that inside this radical now, as I've worked out that this is the same as what my input is on my radical. So now I've got I square root of square root of 3 minus or plus 1 squared. Okay, right. Now if I take the square root of this squared term, I'm just left with what's actually inside the radical, inside the bracket. So now I'm left with z equals plus or minus I, and then I've got square root of 3 minus or plus 1. Okay, so now I can write out my 4 solutions. So as this is to the power of 4, I will always get 4 solutions. So now I've got z equals I, so positive I, and square root of 3 minus 1 times I. So square root of 3 minus 1. And also in here I can have the plus 1. So z equals I square root of 3 plus 1. So that's my first two with a positive I. So I'm going to call that Z1 and Z2. And then I've got Z3, Z4 I can now find. Z3 equals minus I root 3 minus 1. And Z4 equals minus I root 3 plus 1. Okay, so that gives me my 4 solutions to z to the 4 plus 8z squared plus 4 equals 0. Okay.